Hey y'all, this is just a quick video on using Pythagorean theorem in three-dimensional figures. Okay, so let's take a look at this problem. A straw is placed inside a rectangular box that is 10 inches by 8 inches by 9 inches as shown in the picture below. If the straw fits exactly into the box diagonally from the bottom left corner to the top right back corner, how long is the straw? Leave your answer in simplest radical form. So that means we're leaving it with our square root, okay, intact. We're not estimating here, okay? So how we're going to do this is that we are going to draw our triangle and what it's going to look like, okay? So if we have the diagonal triangle, that means we can kind of cut across the center bottom here and create a triangle that sort of fits into the middle of this box. Okay. Picture like a piece of paper slid diagonally into a box, and obviously it's just a triangle as opposed to a whole rectangular piece of paper, but it's just a thin triangle that fits diagonally in that box. Okay, and then the hypotenuse of that triangle is the straw that we're talking about in this problem. Okay, now in order to determine the length of that diagonal, we need to first find the length of this diagonal here at the bottom. Okay, and that diagonal that I've drawn here in the dotted line is the hypotenuse, or C, of this triangle here that is labeled with the 8 and the 10. Okay, so hopefully you can kind of picture that. And then there's a right angle here on the floor of this box. Okay, now we're going to use our same formula here, a squared plus b squared equals c squared for our Pythagorean theorem. And in this particular part of the problem, we are, our a is 8 squared, and then our b is 10, and we're going to square that, equals our c squared. Okay, so as we solve this, we get 64 plus 100 equals c squared, and that's going to be 164 equals c squared. So your solution here is the square root of 164 equals c, okay, because we're square rooting both sides here. All right, now, so that means c right here is the square root of 164. I know that's kind of ugly, and you really want to turn that into you want to estimate that number there, but our full answer is in radical form. We never estimate, or we never round a number until we are completely finished the problem. And this particular problem doesn't want us to round it at all. Okay, so we absolutely cannot round these problems in the middle. We have to leave it in this radical form, okay, with the square root. All right, so now we know the length here, the diagonal at the bottom, is the square root of 164. This height here is not perfectly labeled, but if you'll remember in 3D figures that all of the heights, no matter where it's at, are exactly the same. Okay, and the height is labeled right here as 9 inches, which means this height in the back here is 9 inches. Okay, I'm going to clean up this figure just a little bit so we've got a few less lines. Okay, and I'm going to change my color here so I can kind of demonstrate a little easier which triangle we're looking at now. Okay, we're going to look at that same diagonal, but now it's like a magenta-y pink color. Okay, and so that's the triangle that we're looking at that's attached to the straw that goes through my figure here. Okay, so now we have um, our square root of 164 and 9 as our A and B, because our right angle is now here. okay? And the opposite is obviously our hypotenuse. So now our new C that we are trying to figure out that will in fact give us our final solution here of the length of the straw is here. Okay, so this is no longer C. We just know that it is now a leg in our new triangle. And we're going to use that same formula, a squared plus b squared equals c squared. Okay, our new a is going to be 9, and then we square it, and then the square root of 164, we will square that. Now, we know from previous experience that when we square root a number, okay, it just becomes the base, okay? And so my base here is 164. So as when I square the square root of 164, that is going to equal 164. Okay, if we need to think about that in simpler terms, you can think of if I have 4 squared, that equals 16, right? And if we square root 16, we end up with 4. Okay, so you can kind of see that the square root of 4 squared is, in fact, 4. So the same is going to be true when we get a bigger number, such as 164. Okay, and that is all going to equal c squared. That 9 squared is that 81 that I've written here. Okay, so from here, we are going to add our 81 plus 164. We get 245, and that equals my c squared. Okay, and again, we need to know what just C is, so don't forget that last step of square rooting your number. And so this C is equal to the square root of 245, and that is your solution there. Okay, so it is a multi-step Pythagorean theorem problem. You have to find the hypotenuse of one triangle and then use that information to apply it to your final triangle that you're looking at there. Okay, so this is definitely a more complex problem, but that is how you would use Pythagorean theorem to find a diagonal through a 3D figure.